The eighth question you will do it last, Ada.
Eighth question.
That variable limits plus something was there, right?
Oh, that question. Do it on your own. No, you're talking about this question.
Okay, right.
This question. This question you're saying. Do it on
Okay,
your own.
that was given by ma'am, right? So had she given an answer?
I don't know. I don't think she's getting. Yeah, you can see the class. Yeah, she's all these questions are from ma'am sheet only. Nothing I've taken.
Okay, right. Then no.
Okay. Now we will start geometrical interpretation. First of all, there's a lot of theory in this which you have to thoroughly understand before entering actual integration. Do this carefully. Suppose you are describing about single integrals, and I'll type it. You see, single integrals. Look at this carefully. Try to understand the logic. You will write y, you write h into dx, right? For single, this is what you did in, you wrote, you can also write as y dx. This is what you did in 12th level, correct? To calculate area. Now you just check the dimension. If you do dimensional analysis, integral h dx, this has dimension L. This is dimension L equal to L squared. This is a dimension of this. Meaning, single integral will help you calculate area. Clear? Single integral will help you calculate area. Similarly, if you take double integral, you will calculate. I will see double integral 1 minute. I will write one by one. Now see double integral. If you see double integral, you will be writing integral h into dx dy. What is dimension? L into L equal to L cube. Meaning what you are calculating? Volume. I don't know. You are calculating volume. Now, if you are taking triple integral, you will be doing integral h into dz dy dx. So dimension will be L into L into L into L equal to L power 4. We don't have a specific term to define. We can just say 4D space, 4D, something in 4D space. We don't know the correct terminology to give. Okay, so we will not discuss about terminology. Use carefully. In single, now come back to single integrals. In single integrals, imagine I am put, now what is this? This is nothing but this is 1D part. This is 1D, and this is the 2D extender. Dx is only 1D. H is representing 2D extender. Try to understand the logic. Now, suppose I'm putting h as 1. Suppose I'm putting h as 1. Can I say integral dx will be 1 into length? So this will represent length. So can I say if the height function is 1, single integral will represent length. If h is 1, then single integral length is equal to area. Single integral represents length. Try to understand the logic. You can say similarly, here if h I am putting as 1, then I can say it will be integral will be equal to 1 into length into breadth equal to area. So I can say if h is 1, then I can say double integral calculates area. Similarly, if h is 1, triple integral calculates volume. But that's only if h is 1. If h is not 1 and something else, it will calculate volume only. Similarly, if h is not 1, it will calculate area only. Okay. This important logic please tell me if everybody are able to comprehend. Very, very important logic. Are you all able to understand? I want response because it's very important. Any sort of confusion in this?
Got it.
Hmm?
Yeah, we understood.
Understood. Very good. Okay. One has confusion, please ask. Very, very important to understand. It's all.
Rachel,
Yeah,
and
ask,
if
ask.
h equals to other constant, it will be the same thing, right? It,
No,
it
it's
should
other,
be
no.
more like h is independent of x and y, right?
Not like that. If
Not like that.
no, it's not like you think and see. Suppose I'm putting h as constant, then integral will be constant into length. Constant into length is area. Length is not equal to area.
How come? Like suppose integral 2 dx, it will be 2x. Suppose
That
x is length, then it will be just length, right?
No. 2 will make it area. You see, integral 2 dx. Suppose I'm integrating from 0 to 1. I am taking a region x equal to 0 to 1. Okay, and 2 means I'm extending the height as 2. So this is area, you know.
Okay.
Understood? If you put
Okay.
as 1 only, it will be what? It will be 1 now. What 1? This is 1 only. No. So that
Okay.
time it will be length only.
Okay.
Understood? So it can't be constant also. It should be only 1. Even if it's constant, it will increase. No. See, think. Okay. This is not understand. Very good. Good question. And I hope everyone understood what she asked and what I said also. Should be simple. Okay. Should be clear. Okay. Now we'll enter the concept of. We'll see. Calculation of area. Okay. Calculation of evaluation of different integrals. We'll directly see a question because through question only we can understand, correct? Through question only we can understand. Look at this carefully. They are telling, they're giving the integral as xy dx dy, and they're giving region as R. Find integral. And they have described region R. Listen carefully. It will look very new, it will look very difficult initially, then after it will become very simple. Don't worry. You are taking R is region bound by axis x equal to 2a and x squared equal to 4ay. Okay, so they're telling you, you integrate this around this region. It will be confusing. Wait, I'll explain, then we'll see whether you understand. First of all, we'll see what we are evaluating. Are we evaluating area or we are evaluating volume? Someone tell me. Someone tell me what we are actually calculating. Are we calculating area?
Volume.
Huh? What are we calculating? Answer is we are calculating volume actually. You will tell me x there, no, so dimension is L power 4, you will tell. No. Dimension is L cube only. Because you will have a constant which has dimension L power minus 1. The whole, this is height function. This is height function. Height function is xy. This should be dimension 1, you know. So there will be one constant utilized. So we are having length into length into length. We are calculating volume. So this integral actually, we are calculating a volume. Any doubt on this? Too confusing, huh?
Prajwal, one doubt there.
Tell me, ask.
How can you define the dimension there? Like if we are saying one is having L power minus 1, what supports it to be true? Like I can take it as L power minus 2 or anything.
Physics, all this is physics here. Like I've seen, they will take you in physics. You will write this. You will write a equal to t squared. No, you will write all functions. How dimension is incorrect? No, this is meter per second squared. This is second squared. How you are writing? You are actually introducing a dimension. You are introducing a constant one which has one particular dimension. Meter into second power minus 4. Physics, you written everywhere. No, you will differentiate this. You will integrate this. You will find v. You will find t cube by 3. Father, how you wrote? Because you are introducing dimension. You are introducing a constant which has some dimension.
Oh, okay. So in this question, initializing itself, we are calling it as an area. Like starting itself, we are saying this answer should give us a area. I mean volume.
Volume
Is
only
it like that?
because it is. I told you, because it's some height function into dx dy. Look at this. It is height function to dx dy. Height should be length
Okay.
only. So it's calculating volume only. Understand? Now.
Oh, so xy together is height.
Exactly. That's a height
Okay.
function. Whatever function you're writing here is height function. Okay.
Okay.
Now try to visualize. Now we'll try to visualize. Listen carefully. So the
Rajul,
region.
I still have doubt in that previous part, like integral 2 dx, right? We can like take 2 outside the integral because it's constant. So it'll be like twice the length, right?
Yeah, but still 2 will have dimension. I just don't know. 2 also has dimension. 2 is not dimensionless. This is 2 meter. 2 meter into integral 0 to 1 dx. This will become 2 meter into 1 meter. Still it's 2 meter squared only.
I still can't understand, but leave it. Just go. Go ahead.
Yeah, what is the not understand? See, think no. 2 dx you are doing 0 to 1. Okay. This is what? This is 2 meter.
Yeah,
This
but
is
we are
integral 0.
assuming it, right? Like,
Yeah, you have to assume. That's what don't assume. You are assuming. You have to assume. Hey, don't think. Don't overthink. Okay.
okay.
Don't overthink.
Yeah, just leave.
Okay. Any other doubt, I'll clear later if you really have more doubts. So, okay, look at this. Now you see this question. This region, first you'll try to draw this region. If you look at draw this region. X-axis, draw x-axis. Okay, draw the x-axis. Now draw this parabola, upward parabola. All this is you should know to draw. Okay, you should know to draw. Don't ask how to draw and all. Okay. So this is line. This is the coordinate. This is line x equal to this is x equal to 2a. This is y equal to 0. This is x squared equal to 4ay. Correct. Listen very carefully. Tell me which is the area which is bounded. This is the area. This is the area bounded. Correct. This is the area. Correct. Listen carefully. This is 2D. So what happens is, actually what is this area? This area is nothing but this is the volume of some solid. This is volume of some 3D figure. The area that we have shaded here, shaded area. Shaded area is nothing but projection of 3D figure on XY plane. Actually, shaded area is a projection of 3D figure on XY plane. The 3D figure will be something very you can't even think of the 3D figure. Some other will be. You project on the XY plane. This is how it will appear. Okay, and we don't have no need to visualize that. No need to visualize. If you visualize just this, visualize only 2D area. That's more than sufficient. Don't try to visualize how the 3D figure looks. You can't. 3D figure you will multiply x by c. Here x by 0, height is 0. Here height will be 0. Here height will be some x into y. So here height will be some another x into y. Height will keep changing. So it will be some complex figure you can't even imagine. So don't imagine. Okay. So now your focus should be only on visualizing the 2D area. That is this region. You only visualize this. Don't need to visualize anything further. Now we will see the actual integration. Look at this carefully. So I'll just read out the figure in 1 minute. So we're having like this. We're having not neat. Like this. We're having like this. Let me draw it smaller. Be better. Okay. This is the area. Now to cover this area, I can use 2 types of strips. 2 types of strips. I can take horizontal strip or I can take vertical strip. Okay, let's just see how I'm doing this question. I will concentrate on this region or this region roughly. This is the region that is there, correct? this region. Okay, this region, I have to find the area. Hope it's visible. What I'm doing, I'll take a horizontal strip. Okay. Now you just think, okay, for horizontal strip, throughout the strip, you can say y is constant and x is variable. Try to understand. Throughout the strip, horizontal strip, y is constant, x is variable. X is varying from, what is this curve? This curve is x squared equal to 4ay. Here at this point, x will be root of 4ay. X is root 4ay, and here x is 2a. What is the line? Doubt in anyone having doubt in this, please ask. See, throughout the strip, y is constant, x is variable. X is varying from a. See, this curve is what? X equal to root 4ay. This curve is what? X equal to 2a. So I am drawing the strip like this. Now, next, now move the strip. How to move the strip? Initially, there will be a strip here. Finally, strip will go here. Strip is moving in this direction. This is movement of strip. Strip. When the strip was here, y was 0. When the strip is at this point, what is y? How to calculate this point of intersection? We calculate. This point of intersection will be, I think, 2a comma a. Y will be a. This concept, is it clear? Initially, I am fixing the strip in one area, one place I'm fixing, and I am seeing x is varying from root 4a to 2a. Then I am moving the strip. Here y was 0, here y is a. Now I get the integral. Integral. First I will vary x. X equal to root of 4ay to 2a xy dx. Then what I'll do? Then I'll move the strip. I'll move the strip from y equal to 0 to y equal to a dy. This is the integral. Now you sit and calculate the value of this integral. Any sort of confusion in this? Let's finish all this integral. Any sort of confusion anyone is having, please ask. You are free to ask. This is the visualization, that's it. So y into x squared by 2. You will get x squared by 2 means you will get 4a squared minus 4ay. This will integrate from 0 to a. Do integration. Waste my time. Tell me, all of you are clear with this? This is how you write limits. One response.
Yes, it's
Got
clear.
it done. Yes.
I have one doubt. Like we are taking rectangular strips, right? So some part of area is going to be missed, right? Like it's a curve right there, so some sort of area will be missed, right?
Differential strips. Differential strips means very, 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 very small. So don't worry, okay. This is differential calculus. Differential calculus, now what you will differentiate now, you're differentiating so tiny parts, then you're integrating all differential calculus. Okay, I hope this doubt is clear. Now listen carefully. Same question, but now I am taking vertical strip. Same question, I am taking vertical strip. Let's try this. So if we take this region, the region is like this. Right now, try vertical strip. I didn't close the diagram properly. Oh, yes. Now see, take vertical strip. We're taking vertical strip. For vertical strip, take like very small. I think it's very small. Okay, it's not big. This is very big. This is the vertical. The strip will be 1000 times lesser in size than what I have drawn. Okay, so the small parts are no problem. Don't worry. Okay, so throughout vertical strip. So in a strip, in a vertical strip, what is constant? X is constant, and y varies. Tell me. Here y was 0. Here y is x squared by 4a, correct? Here y is 0. Top y is x squared by 4a. Now move the strip. Now move the strip. How to move the strip? Take the initial strip here. Take the final strip here. That's it. Over. For the initial strip, x is 0. For the final strip, x is 2a. That's it. So what you will do? Integral 0 to x squared by 4a xy dy. Finally, integral 0 to 2a dx. That's it. Over. This is how you will write the limits. Is it clear? Any doubt in this? Like I will solve the full question and put as PDF. Okay. Now I don't want to waste time solving the question. I will solve it till the end. I will put both. I will put the answers. Okay. So don't worry about finding the answers. Worry about whether you're able to understand how to write the limits.
Like if we take vertical straight, we will write dy first and then dx. And if we take horizontal straight, we will write dx first and then dy.
You don't have to memorize that. For the horizontal strip, initially y is constant. X is variable. So first variable will be x. Then we are moving the strip, that time y is varying. So finally you integrate y. So you see here, when you are writing vertical strip, through the strip, x is constant. Y is varying. First you integrate y. Then you are moving the strip, and you are moving the strip like this. Here you will move the strip in horizontal direction like this. When you are moving the strip, x is variable. That time you finally integrate respect to x. Nothing more. And you only have to think like that. When you are writing limits, you are getting 4ay, no? So this is limit for x1, no? Can this be limit for y? Writing root 4ay, it has to be limits for x only. You're writing x equal to root 4ay to x equal to 2a, meaning first you integrate x1, no? First you will write what you're writing for one strip. This is one strip. Right, like this is for one strip. Yellow part is you're moving the strip. Orange part is for one strip. Then finally you are moving the strips. Then move the strip. Okay? Nothing to memorize. All logic only. Can I proceed to one more question?
Yes.
Okay. Now, that's it. I'll do only one question, one model. Now, this is another model. This is carefully. Now, evaluate the given. Okay. Changing the order of integration. Changing the order of integration. Now, what is this word? Changing the order of integration. Looks new. We'll see what is this. Okay. Carefully look. I am saying the integral is integral 0 to 3 integral x squared to 9 x cube into e power y cube dy dx. Okay, this is the integral. Now to solve this integral. Now and this question. Okay, we'll see this question. So we'll see how to solve this question. Carefully. Now they have not given you region here. Limits are directly written. Limits are directly written. So you will think, oh, limits are directly written. Then you know it is like first model I gave. See, it's like this. So think like this. Oh, that's a very simple. But just try to integrate this. Try to integrate this and see directly. Try it. If you're able to integrate directly, tell me what's the answer. If you're not able to, tell me what the problem is. Yes, tell me. Are you able to get the answer directly?
I think we have to substitute, like change. I mean, e power y cube is there, right? So,
Tell me what is substitution. You're trying substitution. Tell me. You are doing integral x squared to 9. Initially dy, because this is limits for y. See, this is limits for y. And this is limits for x. Okay. So this is limits for y I'm writing. I'm writing x is constant. So I'll write integral e cube dy. And I'm integrating this. And finally I'll integrate 0 to 3 dx. Tell me, can you evaluate this integral? Is it evaluatable? Is it evaluatable? Tell me, Aditya, what substitution are you going to perform? Tell me. You'll put y cube as t, yeah? Try and see, no? Where you have
That's
d.
what I'm trying.
You won't get it.
Beta. Yeah,
How will
yeah,
you get?
fine. Yeah.
3y squared dy is dt. Tell me. You have only dy. Where is y squared? You have y squared, no? Okay. You have y squared, no?
Square I
Okay.
can write it as I mean 3 into t power 2 by 3 I can write it, right? Like
How will you integrate that? E power t into t power 2 by 3. You think you will integrate this?
yeah, no, that is not
There's
working.
some
That's why.
formula not to integrate.
Huh?
There's some formula not to integrate. Like this.
How you, there's no formula to integrate this? No. Try, okay. If it's possible, if it's really possible, then I'm
Yeah,
happy.
there's some integral f of x into g of x dx is something like f of x integral g of x.
So you're talking
And
about
integral
Like
f
by
dash x.
by
by
parts
parts.
you're talking
I
about.
don't remember.
Okay, see, all that is complex. Okay, it may be possible. Even by parts may work or may not work.
By parts.
Okay. So what we'll do is, that is why we are bringing this concept. Okay. Let's understand what it is. First step is you visualize the limits. Visualize 2D area. See, this is the height function. We are calculating volume. But we don't have to worry about that. We will visualize the 2D area. How to visualize? Draw the diagram. What curves you are drawing? You are drawing y equal to x squared, y equal to 9, x equal to 0, x equal to 3. Draw all these 4 curves first. Draw y equal to x squared. Draw it. How it will be like this. Oh, you're not drawing neatly. Like this. X equal to 3. It will be like this. Y equal to 9. I think it will be like this. Just what is the point? Wait. I don't want to draw wrongly. This is y equal to x squared. This is x equal to 3. What is the point of intersection? 3, 9 cut, that only. So y equal to 9 will come like this. And x equal to 0 will come like this. Okay. Now we are having this bounded region, this bounded region. Someone tell me which bounded region area they are calculating. Here we wrote the limits by seeing the figure. Now you draw the figure by seeing the limits.
The upper part, right? Like because the lower limit is x square, so
simple. Upper part they are writing. Why? Now first of all they are taking horizontal strip or vertical strip. They're taking horizontal strip or vertical strip. Initially they are varying y by keeping x constant. Meaning initially they are keeping x constant. Meaning they are taking vertical strip. Clear? Deep analysis you should do. And here lower limit is y equal to x squared. Upper limit is y equal to 9. And strip they are varying from x equal to 0 to x equal to 3. Understanding? So this is the area they are calculating. Now they are not calculating area. This is the area, and this they are multiplying by height function to calculate volume. This is the area they are focusing on. This is the 2D area. Listen carefully. What is the meaning of changing the order of integration? Can someone guess? What do you mean by change of order of integration? Changing order of integration. What is the meaning of this? Can someone guess? Tell me. No guess, sir.
Taking horizontal strips instead of vertical strips, or taking vertical strips instead of horizontal strips?
You got it. In the question, if they are given horizontal, you convert to vertical. In the question, if they are given vertical, you convert to horizontal. That's it. Or whatever strip they have taken, you do the opposite operation. That's it. Reverse strip used. Change the strip used. Right, like that. Do the question on your own now. I'll also keep doing. You also try. So in the question they are given vertical strip. We don't like vertical strip. Why we don't like is we are not able to do the question. Seriously, when we try to do the question using vertical strip, we didn't get the answer. Okay, no problem. We will try to do using horizontal strip. How to do? Yeah, you'll have like this, like this. Oh, this region. Take horizontal strip. Take horizontal strip. What will happen? Horizontal strip na y will x will vary. X is 0. So this is y equal to x squared. So x equal to root y. And strip is going to vary from where to where? Strip y to 0 to y equal to, what is this? Y equal, that's it. Write the integral. New integral is integral 0 to root y, integral 0 to 9, e power y cube x squared. What is it? E power y cube. X cube equal by 2 into ex dy on right. I will do it. I will do it. What will do? Do this carefully. Now if you are dividing this integral, here this constant on we are integrating with respect to x initially, this integral. So I'll take e power y cube outside, integral 0 to root y, x cube dx, then let it dy. You let it. Integral 0 to 9, e power y cube by 4, x power 4 you will write. So it will become y squared dy. See. Now are you able to visualize? Now you can take this also. Now this is it. So now you take substitution whatever you want. T equal to y cube you take. So you will get dt equal to 3y square dy. Now this is single integral. This you can do on your own. I'm not going to waste time. 1 by 4 into 1 by 3 integral 0 to 729 e power t dt. So this will be e power 729 minus 1 by 12. I don't. I hope my answer is right, but logic understanding. Is there any sort of confusion in this question? Are you all understanding what is the meaning of changing the order of integration? Any sort of confusion in this? If it exists, please ask. Can I proceed?
Yes, sir.
Simple, na? Any doubt in this? See, changing order of integration means question is again horizontal strip, you change it to vertical strip. Question if they are given vertical strip, you change it to horizontal strip. That's it. That's the only thing. Nothing begin changing order of integration. Okay. Now, questions. See, I can't do many questions. Okay. I can do only limited number of questions. I hope concept is reached. We'll see one last concept. Another 10-15 more minutes. I'll end the class. Transfer of variables. That is changing the variables itself. Changing variables itself. Tomorrow we'll do more questions. Okay. Tomorrow only one more concept and 2 questions are there, and we need to have one more class I think for volume. I mean triple integral, not volume. Changing variables of integration. Give me just 1 minute. Let me see. Just taking the question. It's there in ma'am's sheet. Just taking your sheet. 1 minute. Where is the integral calculus? Yes. Yes. Look at this question. Now first we see the logic. Imagine you're having integral h into integral dx into dy. And now I am writing u as one function of x and v as another function of, oh sorry, not function of x, function of x comma y. And g as v as function, another function of x comma y. That is, you are changing x comma y, you are changing as u comma v, you are changing variables. Change of variables. What will happen? We'll see. Listen very carefully. You change the variables. Integral will transition carefully. When changing variables, you need to substitute function what is given. You also need to substitute the dx dy. How to substitute dx dy, that I'll tell you. Substituting dx dy. Dx dy is equal to mod of Jacobian into du dv, where Jacobian is given as, what is it? Dou of x comma y by dou of u comma v. This is how you will transform. This is substitution of dy and appropriate substitution. Substitution must also be carried out in height function. Okay. So again theory. We'll do a question. Then we'll come back to theory. Any doubts you can ask. Look at this question. We are giving evaluate integral 0 to 1 minus x e power y by x plus y dx dy using the transformation given. What is the transformation? Transformation given is x plus y equal to u and y equal to uv. Need to perform this transformation. How to do this question? We'll see. First you calculate Jacobian of this x comma y, u comma v. How to calculate Jacobian of this? First you try to express x and y in terms of u and v. Look at this. I'll tell you what I mean. Y you are having as uv. Now x plus y is u. X plus uv is u. So x equal to u minus uv. So you are having x is u minus uv, comma y equal to uv. Highlight this and keep it ready. Highlight and keep ready. Now you are writing find Jacobian of x comma y by u comma v. So Jacobian operator I have already taught you. How you will write it? You will write dou x, you will write dou y. Then you will write dou u, you will write dou v. Please evaluate it. I want to evaluate this. Okay, waste of time for me. I tell dou x by dou u. You shouldn't do dou x by dou u. What will be? It will be 1 minus v, I think. Dou x by dou v. Dou x by dou v is what? It will be minus u. Dou y by dou u is v. Dou y by dou u. Please take the answer. I don't want to give wrong answer. Correct? I know what I done. Hope it's correct. Yeah, I told you. So it will be u into 1 minus v plus uv. U minus uv plus uv equal to u. So Jacobian equal to u. Clear? You have done this. And one more thing I forgot to tell you. This is modulus value. You will take mod as I know. This is modulus. Don't worry much about it. Just take Jacobian value. Okay. This is Jacobian clear. Jacobian I'm not going to clear in doubt. Like Jacobian you got as u. That's it. Now look. Now I'm getting a new integral is integral of, give me a moment, new integral is what? Integral of integral e power y is, what is y? Y is uv, x plus y is what? X plus y is u, and dx dy you're writing as u into du dv. Get out of this integral e power v into u into du dv. Tell me, this is a new integral, correct? This is the new integral. Now limits you have to change. Focus carefully. Limits also you have to change, but you cannot change limits directly. You can't just write 1 minus x. Now you can't write 1 minus u plus. You can't write like that. No, you have changed. No, you have changed the variables. Now you need to change the limits. Now you need to change the limits. Change limits. How to change limits? You need to draw a diagram. So please confirm because it's a very big question. Tell me. How we change the limits? Dx dy wrote as u into du dv. This is all dx dy. Now limits have to change. Limits how to change? Listen carefully. What are the old limits? Old limits I'll write first. Old limits are y equal to 0. X equal to 0. X equal to 1. Y equal to 1 minus x. Y equal to 0. First to draw this diagram. This diagram if I'm drawing, I will get x is 0, x equal to 1, y equal to 1 minus x, y equal to 0. what I'm getting? I'm in triangular region. Triangular region, this is y equal to 0, this is x equal to 0, this is x plus y equal to 1, correct? So this is useless, this is useless, so don't worry about this. So you're having a triangle, this is the old limit. Old limit is saying you're having a triangle bounded by x equal to 0, y equal to 0, x plus y equal to 1. Now how to write new limit? Listen very carefully. New limits now I'm writing. Very, very important, listen carefully. What is x equal to 0? X equal to 0 means, what is x? X is uv equal to 0. Meaning u equal to 0, comma v equal to 0. Next I'm writing, what is y equal to 0? Y equal to 0 means u minus uv equal to 0. U minus uv equal to 0. This will give you u equal to 0, comma v equal to 1. And third line is what? X plus y equal to 1. X is what? U v plus u minus uv equal to 1. This will give you u equal to 1. Clear? Are these limits clear? Go very slowly. Tell me, is it clear? I want response. Without response, I want to proceed. Response. Here I know.
In first and second, you have, I mean, ulta, you did it reverse, like x is u minus uv and y is uv.
ஐயோ ஃபர்ஸ்டே சொல்லிருக்கலாம். ஓகே சொல்றேன்.
அத அப்படியே மாத்திக்கலாம்.
So okay, wait, x equal to 0. Tell me fast. U minus uv equal to 0.
Equal
so
0.
U is 0, v equal to 1. Now y equal to 0 will give you uv. Y is uv equal to 0. So you will get u equal to 0, comma v equal to 0. Then you will get x plus y equal to 1. You will get u equal. You will get what? X is u minus uv. Y is uv equal to 1. You will get u equal to 1. Okay, yeah. Now clear. Can proceed. Proceed. Tell you tell Aditya. Can I proceed?
Right.
Look at the new limits. Now you are drawing u equal to 0. What are all the curves? U equal to 0, v equal to 0, u equal to 1, v equal to 0, v equal to 1. Now plot in uv plane. See, plot and see now. You're plotting and seeing what you're getting. Plot and see. Getting what are the first name the line? This will be u equal to 0 because this is uv plane. See, this is uv plane. Okay, this is u equal to 0, this is u equal to 1, this is v equal to 0, this is v equal to 1. What is the bounded region now? Square. So just look at transformation. Look at the beauty of transformation. So transformation, it converted triangle to square. Imagine the transformation you made converted triangle to square. Appa, think of this transformation, no? Triangle became square. Can you imagine? Triangle became square. See, now it's easy to integrate. Now you take strips properly. Now I'll take x strip. I'm taking x strip. I'll take x strip. Tell fast this question. I'm ending the session. Look at this carefully. Take x strip. So taking x strip. X will vary from, sorry, not x strip, this is u strip. I'll tell you this is u equal to 0 to u equal to 1. And then this strip will move along how much? It will move from v equal to 0 to v equal to 1. Correct? So perform integration. I'll write u equal to 0 to u equal to 1. V equal to 0 to v equal to 1. And what is the function? E power v into u du dv. This is separatable. This is separatable. V integral 0 to 1 e power v dv into integral 0 to 1 u du. This will be e minus 1 by 2. See this question. Is it nice? This is called integrating by transformation. Very hectic only, I know. This is very hectic. It will kill you. You need to transform variables, find Jacobian. Then you need to write new function. Then you need to write new limits. For new limits, you need to visualize old function. Then you need to visualize new function. Lot of work is there, I accept. But do it. For examination sake, you have to do it. Okay, that's it. Today's class I'm ending here.